Bismillahirrahmanirrahim. Assalamu alaikum dear students. Hope you all are doing well. I'm your maths teacher, Teacher Umaira. We are discussing chapter number 12 in these days. Chapter number 12 is about line bisectors and angle bisectors. In this session, we will cover theorem number 12.1.4, theorem number 12.1.5, and theorem number 12.1.6. Let's start our today's lecture with theorem number 12.1.4. First of all, we will see the statement of the theorem. Dear students, statement of any theorem gives us some important hints to draw the figure. To draw the figure correctly is very important part of the theorem, as the whole theorem depends upon the correct drawing of the figure. So now we'll see that what does the statement of this theorem tell. The statement tells that any point on the bisector of an angle is equidistant from its arms. Means there is an angle which is having a bisector, and on that bisector is a point that is at the same distance from the both arms of the angle. Now let's see how we will draw a figure by using this statement. First of all, we are going to draw an angle. You know that an angle is always formed by the intersection of two rays. Here we have drawn this ray OA and this ray OB, which both are meeting at point O, which is also called the vertex of angle. So we have formed this angle, angle AOB. Again, we will see the statement. The statement again tells that the angle is having a bisector. Dear student, bisector is something that divides the angle into two equal angles. Bi mean two and sectors mean portion. Means this bisector OM, we have drawn a ray as the bisector, and this bisector OM divides this angle AOB into two equal angles, angle number 1 and angle number 2. These two angles are equal angles. Now again we will see the statement. The statement again tells that any point on the bisector, mean we have to take a point on this bisector. You can take this point anywhere on this bisector OM. I have taken this point here on this place and I named it P. First, we will join this P by this ray OA and this point P by this ray OB, which is forming this point Q and this point R. I will join this point P with this ray OA in such a way that right angles are formed on both sides. In mathematical language, I will say that I have drawn a perpendicular from this point P on this ray OA and from this point P on this ray OB, which gives two other points that are called R and Q. Here we can say that this is perpendicular PR on this ray OA and this is a perpendicular PQ on this ray OB. Next, an important step of the theorem is to write given. Dear students, given is always written by using the statement and by using the drawn figure. First of all, we will again see the statement. The statement tells us that there is a point on the bisector of angle. We have named that point and that bisector and that angle also. So we will write the whole statement in this mathematical language. A point P is on OM bisector OM, and the OM is the bisector of angle AOB. So we have written a statement. A point P is on OM and OM is a ray and the OM is also the bisector of angle AOB. This line segment with arrowhead shows that this OM is a ray. Now the next and important step that we write in our theorem is to prove. To prove is something that is written by using the statement of the theorem and by using the drawn figure. we know that there is a point on the bisector, and we are going to prove that this point P is at the same distance from this ray OA and this ray OB. Mathematically, we will write that PR is congruent to PQ. PQ line segment is congruent to the line segment PR. Here we are not going to write the is equal to sign. We will use this congruency sign because we don't know that what is the exact mathematical measurement of this PQ and this PR. In form of a statement, we will write that P is equidistant from ray OA and ray OB. Next step of the theorem is to write its construction. Construction is what we have drawn ourselves in this figure. We have drawn a perpendicular from this point P on this ray OB and a perpendicular from this point P on this ray OB. So we will write that draw PR, this PR perpendicular on ray OA and PQ perpendicular on ray OB. This bar shows that PR is a line segment and this ray shows that OA is a ray. The last and most important part of the theorem is writing its proof, as it contains 50% marks of the whole theorem. It consisted of two columns. In first column we will write the statements, and in next column we will write the reasons. In this theorem we will see the figure that in our figure two triangles are formed. Here first triangle is triangle PRO and the next triangle is triangle POQ. We can prove that this line segment PR is equal to the line segment PQ by using these two triangles, by comparing these two triangles. So in our proof we will write that we will compare triangle POQ with triangle POR. In these two triangles, we can see that this side OP is common in both the triangles. So mathematically, we will write that line segment OP is congruent to the line segment OP because this line segment OP is common in both the triangles. Again, we will compare the angles of these two triangles. We know that the angle that is formed on the point Q is equal to the angle that is formed on the point R because we have drawn these angles ourselves. We have drawn perpendicular from this P on Q and this P on R. So we will write that we came to know this from our construction. The next angle that we have drawn in our figure two angles, these two angles that we have drawn by using this bisector because you know that bisector cuts the angle into two equal angles. So we can say that this angle and this angle is equal in measurement. We can also write in our proof that the angle that is formed on O by using these rays P and Q mean the angle that is formed on this angle POQ is congruent to the angle POR. So from where we came to know this? We came to know this from the given of this theorem. Here we can see that two angles and one side of these two triangles are congruent. We have a postulate that if two corresponding angles and one corresponding side of one triangle is congruent to the two corresponding angles and one corresponding side of another triangle, both the triangle will be considered as congruent triangle. In this way we can say that these two triangles are congruent triangle, and in congruent triangles you know that all the sides and all the angles are equal. So we can say that this side PQ is equal to this side PR. So we have proved that this point P is at the same distance from this line segment OA and this line segment OB, means PQ is congruent to the measurement PR, and in reason we will write that these are the corresponding sides of congruent triangle. I hope you have come to know that how will you solve this theorem. Thank you and have a good day. Now we are going to prove theorem number 12.1.5. Theorem number 12.1.5 is the converse of theorem number 12.1.4. Converse means its statement is the reverse statement of theorem number 12.1.4. In this statement, we have any point inside an angle equidistant from its arms is on the bisector of it. Again we are having an angle which is at the same distance from its both arms, and we are going to prove that this is lying on the bisector of this angle. Let's see how we will draw the figure by using this statement. We are going to draw an angle AOB by the intersection of these two rays OA and OB, and we are having this point P. It's given in our theorem statement of the theorem that P is at the same distance from this point, this ray OA, and it is at the same distance from this ray OB. Means the line segment PR is equal to the line segment PQ. This sign shows the equality of these two line segments. In construction, we will join this point P to the vertex O. Now we are going to write given. Given is always written by using the statement and by using the figure. So we will write points from the figure and also from the statement. Any point P lies inside the angle AOB. Here we were talking about a point that is lying inside the angle AOB such that PR and PQ distance are congruent to each other, where PQ is perpendicular to OB and PR is perpendicular to OA. It is also given that this PR is joined by this OB by drawing a perpendicular PQ on OB, and similarly for this ray OA. Now we are going to write the next step of the theorem, that is to prove. We have to prove that point P is on the bisector of this angle AOB. Means this point P is lying on the bisector of this angle AOB, and you know that what is bisector? Bisector is a ray that divides this angle into two equal angles. Now we will write the construction. In construction, we have joined this P to O. Now the next step of the theorem is writing its proof. In proof, we will again write statements and reason. And whenever, dear student, whenever in our figure we have two triangles, we will compare both triangles. Here we will again compare this triangle RPO and this triangle POQ. Means this triangle POR and this triangle POQ will be compared once again, and we will compare all its sides and angles. In comparison of triangle POQ with triangle POR, angle PQO is congruent to angle PRO. It's given that both the angles are right angle. Again, we have seen that this side OP is common in both the triangles, so we will write that PO, or you can also write OP is congruent to OP or PO because it is common in both triangles. Again, we will see this side. This side was given in our statement that this P is at the same distance from OB and P is at the same distance from OA. So we will say that this PQ line segment is equal to a line segment PR, and we came to know this from our given. So we can see that all these two triangles, triangle POQ is congruent to triangle POR, and the postulate we have used here is hypotenuse and side is congruent to hypotenuse and side. You know that these two triangles were the right triangles, and in right triangle we have a property that in right triangle, if hypotenuse of one triangle is congruent to the hypotenuse of other triangles, and one side of the triangle is congruent to the one side of the corresponding side of the other triangle, both the triangles are called congruent triangles. So we are using this property. In this way, we can say that angle POQ, this angle is equal to this angle. Both the angles are congruent angles. So we will write in reason that these are the corresponding angles of congruent triangle. This in this way we can prove that P is lying on the bisector of angle AOB. The bisectors of the angles of triangle are congruent. Mean we are having a triangle in this theorem, and this triangle is having bisectors of all its angle, and all the angle bisectors are congruent. Congruent mean all the angle bisectors are meeting each other at same point. Now let us see how we will draw a figure by using this statement. First of all, I have drawn a triangle ABC. ABC is a triangle. Then I have again seen the statement. In this statement, it is written that the bisector of angles of a triangle. So I have drawn the bisectors of two angles of triangle initially. First, I have drawn the bisector of angle B. You can see that this bisector of angle B is dividing this angle B into two equal angles, and then I have drawn a bisector of angle C. Again, you can clearly see from the figure that this bisector is dividing the angle C into two equal angles. Both the bisectors of B and C are meeting each other at point I. Now I have drawn a perpendicular ID from point I to this to this side BC, and a perpendicular IE from this point I to this side AC, and a perpendicular IF from this point I to this side AB. Next step of the theorem is it's given. Only a triangle is given, so I have written that triangle BABC. In the given we have a triangle, so I have written triangle ABC. To prove, we have to prove that all the angle bisectors of this triangle are congruent. So I have written that the bisector of angle A, angle B, and angle C are congruent. So the next step that we are going to write is the construction of this theorem. In this theorem, construction is something that we have done with this figure by ourselves. So we have drawn two bisectors and three these perpendicular. So we will write that draw bisector of angle B and angle C initially, because first we will draw bisectors of angle B and C, and we will prove for angle A, then we will prove for angle B and C by using some statements which intersect at point I. You can see that both are intersecting at point I. So we have written that which intersect at point I. From point I, draw IF perpendicular on AB, ID perpendicular on BC, and IE perpendicular on CA. All these bars are showing that these all are line segments. And now the next and most important part of the theorem is writing its proof. In writing the proof of a theorem, we always make two columns. First column is for writing the statements, and second column is for writing the reasons. In first statement, you can see that we have written ID is congruent to IF. This line segment ID is congruent to this line segment IF, because they are sharing a common point, that is I, and this point I is on the bisector of angle B. So in reason, we can give the reference of theorem number 12.1.4 that any point on the bisector of an angle of the angle is equidistant from its arms. Similarly, we can see that this line segment ID is congruent to the line segment IE. Again, they are having a common point I, and which is on the bisector of this angle C. So you can see that ID is congruent to the line segment IF, and ID is also congruent to the line segment IE. So we can say that this line segment IF is also congruent to the line segment IE. IE is congruent to the line segment IF, and in reason we will write that because each length IF and IE is congruent to ID. We have proved this. Then we will write that So the point I is on the bisector of angle A. How can we say this? As IE, we have proved that IE is congruent to IF. So we can say that this point I is also on the bisector of this angle A. We consider that this is our first statement. Also, we will say that the point I is on the bisector of angle ABC. Angle ABC, this is angle ABC, and I is on the bisector of angle ABC. You can see that I is on the bisector of angle ABC, and I is also on the bisector of angle BCA, means I is on the bisector of angle BCA. From where we came to know this? We came to know this from the construction of the theorem or construction of this figure also, because we have drawn bisector of angle B and angle C. So in reason we will write that we came to know this from the construction, and at the end we will say that thus the bisector of angle A, angle B and angle C are congruent at I. From this in the reason we will write that we came to know this from equation 1 and equation 2. Dear student, that's all for today's session. I hope you have enjoyed learning with me. Keep on enjoying learning. Stay home, stay safe, take care, and Allah Hafiz.